In this video, I shall be discussing about half-life period. Half-life period means the time taken to complete 50% of the reaction. Okay, so that means 50% concentration of the reactant is left out, or 50% of the concentration of reactant is already used up. Say suppose for example, okay, the reactant gives the product. Now let us take the initial concentration as R0. Okay, then after some time, okay, the amount of reactant left is R. Now if it is half-life period, okay, that means after the reaction, okay, in half-life period, the amount of reactant left will be half of the concentration of the initial concentration. Okay, so it will be R0 by 2. So half of the concentration of the initial concentration is left. Okay, so this is for t equals 0 and this is equal to t of 1 by 2. Okay, then we shall find out the half-life period for first order, zero order and second order. Okay, so let us first see the zero order reaction. Okay, the integrated rate equation for zero order reaction is R0 minus R equals to KT. Okay, this is the integrated rate equation for first order. Now here, if it is half-life period, then T will be T half. This is at the subscript. Okay, and R will be half of the initial concentration, like this. Okay, then we shall substitute. Okay, R0 remains the same. Okay, minus, so this R will become R0 by 2. By 2 equals to KT. We take LCM for this one, 2. So this is R0 0 minus R0 equals to KT. Okay, now this if you subtract, it will be R0 equals to 2K. Okay, this is half, isn't it? Yeah, so like this. Then this 2K you transfer to the other side, so we will get T half equals to R0 divided by K, 2K. Okay, this is it. Then okay, plotting T half versus R0. Okay, the graph will be like this. This is x-axis, y-axis will be R0. Since T half, okay, the half-life period, okay, the half-life period is directly proportional to the initial concentration, so therefore it will be like this. Okay, now I'll give you two tasks. Okay, I want you to find out the half-life period for first order, okay, for first and second order. Okay, and also plot the graph T versus R0. Okay, T versus R0. Okay, for both first as well as second. And for the first order reaction, you find out even the plot of T half versus 1 by R0. Okay, then what you have to do, see, for zero order reaction, what I have used in the beginning was the integrated rate equation. So similarly, for first order and second order, you have to begin from the integrated rate equation. Okay, then the rest you have to follow up. So I think I'll just show you one step. I think, yeah, this is first, second. Okay, so for first order, you start like this, isn't it? Log, okay, R0 by R equals to KT by 2.303. So the next step, what you will do, you shall replace R by R0 by 2 and T by T half. Okay, So the rest thing you follow, you complete it. Okay, then for second order it will be like this: 1 by r minus 1 by r naught is equal to kt. So for this one also you put r as r naught by 2 and t as t of half. Okay, and that way you find out the half-life period for first order and second order, and remember that you have to find out the graph also. Okay, then now let us see a few numericals. Okay, so the first one is rate constant k is equal to 200 second inverse 1. Okay, and we're asked to find the half-life period. I have written the question in short, otherwise it would have been calculate the half-life period of a first order reaction having rate constant as 200 second inverse 1. Okay, but I have not mentioned which order it is. Now in order to find out which order it is, we will come to know from the unit of rate constant. Okay, so for this one you have to go to the previous video, okay, of this particular chapter, and then you see there how to find out the rate constant unit, okay, for first, second, first, second and zero order reactions. Then since this is a first order reaction, okay, so therefore t of half is equal to 0.693 divided by k. You substitute the value of k. Okay, so 0.693 divided by 200 second inverse 1. In the next step, if you, okay, this second inverse 1 minus, s minus 1 will go up, so it will become s plus 1. Okay, so t of half, final answer, you calculate it, solve it by yourself. Okay, at last, okay, you have to write it in scientific notation, so the answer will be 3.465 into 10 to the power minus 3 second. Okay, you have to represent in this form. Then let us try another question. Okay, here so here is a question that is rate constant is given 60 second inverse. Okay, how much time will it take to reduce the concentration of the reactant to 1/10 of its initial concentration? Here also, okay, I have not mentioned the order, okay, but you have to know by the unit of the rate constant. Okay, so second inverse 1 is of the first order reaction. Okay, now the solution is here we shall use that integrated rate equation. Okay, so it will be log of r naught divided by r equals to kt by 2.303. Okay, we shall use this formula to find out the time. Okay, now k already known, okay, except for this part, isn't it? So here it says, you see, how much time will it take to reduce the concentration of the reactant to 1/10? So the remaining concentration, okay, is 1/10 of the initial concentration, is equal to 1/10 of its initial concentration, so which is equal to r naught divided by 10. Clear? Now we shall substitute that r naught, this r value here. Okay, so it will be log of r naught divided by 10 is equal to 60 second inverse into t divided by 2.303. so this one, see, this 2 gets cancelled, this 10 will go up, okay, to the numerator in the next step. Okay, then this one will be like this, it will be log 10 is equal to this 2, you simplify, okay, and find out the value of t. Okay, log 10 value is 1. Okay, log 10 value is 1, so like that. Okay, substitute the values and then simplify it and find out the value of t. Okay, then let us try another problem. Okay, you have to complete this one, you have to complete it. Then let's try another one. So third one, rate constant k is equal to 5.5 into 10 to the power 14 second inverse 1. Okay, it's minus 14. Okay, and we're asked to find the half-life period. Okay, so here you have to figure out first which this is of which order. Okay, second inverse. Okay, so this is of the first order, therefore you have to apply the half-life period for the first order. Okay, so which is d of half is equal to 0.693 divided by k. Okay, this formula you apply and you will get the answer. The final answer is 1.26 in 10 to the power 13 second. Okay, this is of the scientific notation. Okay, you complete the step.